This is Mohammed, Associate Professor in Mathematics from the Lord's Institute of Engineering and Technology. I welcome you all viewers. Today we are going to discuss something regarding the mathematical topic, sequence and series. It plays a very significant role in the field of mathematics and other branches too. For example, let us discuss first some application of the sequence and series, where we are using the sequence and series. Actually, generally, most of the differential equation, they accept the power series summation, and so many mathematical functions are expanded as the power series, like Taylor series, Maclaurin series, and in image processing also, we are using the Fourier series also. And the question arises, when we are expanded some function as the series, when we are substituting some point, how to know what is the value of that series? So that is very, very important. That's why it plays a vital role in mathematics. Today, we will discuss something regarding the sequence and series. Before going to the sequence and series, why? Because this is all depends on the theory of the set and the function. So this is the prerequisite knowledge for the sequence and series. Let us have a look. What is the set? We heard more about the set. Set is nothing but a set is a collection of well-defined objects. So a set is a collection. Every collection cannot be called as or termed as the set. Something is there. What is there? The self, that is the very definition is there. Very definition. So set is a collection of well-defined objects. What we are using in the set, we are using the well definition. First of all, one definition and the objects. Some people they are saying that the set means only the pertaining to the numbers. Not like that. Objects is having a broad sense. Objects may be anything, maybe animate, maybe inanimate, maybe actual, maybe hypothetical. So anything, maybe the many things, maybe the many things come under the object. The object is having the broad sense, and at the same time, it should have the well definition. Well definition. What is the meaning of the well definition? So all the things belong to the same category. That should be there. That type of collection is called as the set. And generally, for the sake of understanding, we used to take what the set of numbers. For example, you can see in the slide, I have taken the example for the set is nothing but the set of natural numbers. The numbers start from 1 to infinity. There is nothing but called as the natural number set, and that is denoted by the capital N. And we are writing in the flower braces, that is nothing but the 1, 2, 3, 4, 5, 6, and so on. We can say that in the broader sense, some other examples also, the set of vowels in English, the set of alphabets, like this. So that is nothing but the set. Set is the collection of the well-defined objects. Next thing is the function. We are taking two sets. We are taking two sets, capital N and capital B, and we are defining the run. What is the rule here mentions? Every element of the set A is uniquely mapped to the element of the set B. That rule is called as the function. That rule is called as the function, and generally we are writing mathematically is as S maps from A to B. For example, I used in the slide a Venn diagram representing a set X and a set Y we have taken, and we showed the mapping by drawing the lines from the element of the set X to the set Y. So that rule is called as the function. Now let us have a look on the sequence. If you understand, if you have the full grasp over the concept of the set as well as the function, we can easily understand what is the sequence. So let us see what is the sequence. Sequence is also a function. It is a function which maps from the set of positive integers or natural numbers to any set S. That's why we are writing as, you can see in the slide, that is F maps from N to S, that is called as the sequence. So basically, sequence is nothing but a function whose domain is the set of positive integers or the natural numbers, and our co-domain is nothing but the set S. And generally, we are denoting this by sequence by the flower braces, that is F sequence F like this. Example, F of N equal to 1 by N we are taking, where N belongs to the set of natural numbers. If you expand this, then you will get this as, for example, we are taking N equal to 1. f of 1 will be equal to 1 by 1. If you take 2, f of 2 will be equal to 1 by 2 and so on. So we can write, because this is a function actually, we can write in the flower basis the ordered bits like this. We can write 1 comma 1 by 1 actually, then 1 comma 1 by 2, 1 comma 1 by 3 and so on. And everyone knows that in the sequence, because the domain is the fixed, that is nothing but the set of natural numbers. So generally we are writing only the range set. Whenever we are talking about the sequence, we are writing only the range set. You can see in the flower basis, that is nothing but the sequence f. We read as this as sequence f will be equal to what? 1 by 1, 1 by 2, 1 by 3 and so on. That is nothing but the sequence. Similarly, we have taken one more example, f of n equal to n square when n belongs to capital N. So which is nothing but, already I told you, we are not writing the domain, just we are focusing on the range. Why? Because that is understood. That's why we are writing for the f of n equal to n square, we are writing as flower basis sequence f will be equal to the sequence 1 square, 2 square, 3 square and so on. Similarly, we can give the number of example for the sequence. Now here, generally we have taken, I told you what is the sequence. The sequence is a function from the set of positive integers or natural numbers to any set S. Even now we are changing what is S. S is also a set. If we take S equal to R, that is nothing but the real numbers, then that particular sequence is called as the real sequence. If you replace S by the set complex number set, then the sequence is called as the complex sequence. So these are nothing but what? Some cases for the sequence. These are the general notations for the sequence. Sometimes we are writing as sequence F, sequence Fn. We are writing as flower basis, that is nothing but F1, F2, F3 and so on. Sometimes we are writing sequence UN, U1, U2, U3 and so on. Sometimes we will write sequence AN, that is A1, A2, A3 and so on. Now let us see what is the meaning of the sequence. For example, if you see in the previous slide, here I gave number of examples for the sequence. Let us take that one, f of n equal to n square, the second example. 1 square, 2 square, 3 square. So that 1 square is nothing but, we can say that is the first element. 2 square is the second element. 3 square is the third element and so on. If I ask you, where is the nth term of the sequence? So that is nothing but, that is already we have taken in the example, f of n equal to n square. So that is the nth term. Now we are enthusiastic to know what is the last term of the sequence. That is nothing but, in other words, as n tends to infinity, what is the last term? What is the behavior of the sequence? That we want to know. So that is nothing that mathematically we are writing, that is nothing but the limit of the sequence. If that number, the last term of the sequence, we are calling at the limit of the sequence. And mathematically we are writing as n tends to infinity. As n increases indefinitely, what is the value of the an? What is the value of the an? That is nothing but we are taking as generally as L if it is exists, that is as L, and that is called as the limit of the sequence. And mathematically we are writing as limit n tends to infinity, an equal to L. For example, we have taken an example here. Limit of n tends to infinity, limit n tends to infinity an, that is nothing but we are taking one example. For example, we are taking 1 by n is the sequence. Now we want to know what is the last term of the sequence. If I apply the limit on that one, we are getting as limit n tends to infinity 1 by n equal to 0. So we can say that the sequence 1 by n, that is nothing but actually the 1 by n, 1 by 2, 1 by 3 and so on, 1 by n and so on. What is the last term? Last term is nothing but 0. So that is called as the limit of the sequence. So whenever we are talking about the limit of the sequence, that is nothing but we want to know what is the last term of the sequence. And based on that term, that is L value, we divided the sequence into 3 types: convergent sequence, divergent sequence, and an oscillatory sequence. There are 3 types based on the limit value. If the limit value is a finite value, then we are calling the sequence as the convergent sequence. If the limit value is infinite value, then you are calling that sequence as the divergent sequence. If the limit value may be finite, may be infinite, more than one value possesses, then that sequence, particular sequence, we are calling as the oscillatory sequence. From name itself, you can understand that oscillates, that assumes more than one value. That is called as the oscillatory sequence. In actual, today what we discuss, first we discuss what is the definition of the set, that is the prerequisite thing. Then we discuss the definition of the function. I hope all of you understood this concept. Thank you, and all.